This particular video is on tree diagrams, and this follows on from the previous video on sample spaces. And if we recall what the sample space is, a sample space is a list of all possible outcomes that we can potentially achieve when we have multiple events. So with tree diagrams, we achieve essentially the same thing as well. So what is a tree diagram? I'll show you what the tree diagram looks like. So a tree diagram usually stems from the first event. So if we look at the first event here, we usually have, let's just say we have three possible outcomes. 1, 2, 3. I could go this way, I could go this way, or I could go this way. And let's just say from event 2, I have two possible ways that I can go. So let's just say I took this event, I took this pathway, I could go here, I could go here, or if I took the middle one, I could go here, I could go here, or if I took the third one, I could go here, or I could go here. So when we look at multiple events, you can see that this eventually turns into something that looks like a tree, because these are what we call branches, and those little nodes that we see there are the particular events that we're looking at. Anyway, I think it's best if we put this tree diagram idea into a particular example just to put some context into it. So the question says a four-sided die is rolled 2 times. Find the probability that the result is. So it's probably best to keep in mind that we're looking at a 4-sided die here, not a 6-sided die. So without even reading the question first, what I'd like everyone to make sure they do is to make sure that you have a look at how many times the event is repeating itself. In this example, the event is repeating itself 2 times. If you look at the next example, the event is repeating itself 3 times. And if you look at the last example, the example is repeating itself 3 times again because it says 3 questions. So once we have a look at how many times it repeats itself, I want you to write down on the top first roll, or first time if you really have to. So from this first roll, we're stemming right there. What are the possible options that we could get from this first roll? Well, from this first roll, we could roll a 1, we could roll a 2, we could roll a 3, or we could roll a 4. So these are the 4 possible options that we could get. So we could roll the number 1, 2, 3, or 4. So I'm going to draw that in a different color. So we could roll the number 1, 2, 3, or 4. Now, from this next roll, when we look at roll 2, what are the possible options we could get from here? Well, if we rolled a 1 at the first, it doesn't really change anything because we can still roll a 1, we can still roll a 2, we can still roll a 3, and we can still roll a 4. And same thing with these other ones. 1, 2, 3, 4, and 1, 2, 3, 4, and 1, 2, 3, and 4. I'm going to put there. So you can see with all these potential rolls, we have all these different combinations that we can get. So I'm just going to quickly draw up here just to make it clear for everyone that's watching the video. This is rolling a 1, that's rolling a 2, that's rolling a 3, that's rolling a 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now if we look at this case, we can see that this actually turns into a nice sample space. Because if we just follow the branches, we can see that if I roll a 1, I can roll another 1. So that means my first potential outcome is 1, 1. What's my next potential outcome? 1, 2. What's my next potential outcome? 1, 3. Or I could roll a 1, 4. With this next branch, I could even roll a 2, 1. 2, 2, 2, 3, or a 2, 4. And if I keep going, sorry guys, I'm just going to move this up here just to get some more space. I could roll a 3, 1. I could roll a 3, 2, 3, 3, 3, 4, or I could roll a 4-1, 4-2, 4-3, or a 4-4. Alright, so now let's look at the questions that we have to answer. Find the probability that the result is an even number. Sorry, this is supposed to, I do apologize, this is supposed to say an even number first. Otherwise, it doesn't build on the next question. So, what's the probability that we roll an even number first? So if we look at question A, how many possible even numbers can we roll for question A? Well, for roll 1, there's 1, 2, 3, 4. We can only roll 2 out of a possible of 4 options. Or in other words, we have a half chance of rolling an even number first. Now let's have a look at the next question. The next question says 1 even and 2 odd numbers. I do apologize once again, guys. This video obviously had a bit of a typo. And 1 odd number in any order. So you can see it says here 1 even and 1 odd number in any order. So let's have a look. Let's have a look at all the combinations that have 1 odd and 1 even. That's 1 odd, 1 even, 1 odd, 1 even, 1 odd, 1 even, 1 odd, 1 even. There is 1 odd, 1 even there, 1 odd, 1 even. There is 1 odd, 1 even, and 1 odd, 1 even. Sorry. So if we have a look at it, how many possible options can we get for rolling 1 odd and 1 even in any order? 1, 2, 3, 4, 5, 6, 7, 8. We can get a total of 8 possible options. And how many possible options can we get in total? Total outcomes can we get in total, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's equal to 1/2. A way I can actually have cut the time by counting is just go 4 times 4. And in this case, 4 times 4 is 16, or we end up with 16 potential outcomes. Alright, let's move on to the next question. The next question says a coin is tossed 3 times. So we're repeating the coin toss 3 times. Draw a tree diagram representing all possible outcomes. So I'm going to go first toss. So for my first toss, what are the 2 possible pathways we can take? We can go here, or we can go here. We can get a heads, or we can get a tails. So with these heads or tails, we can have a look at the next toss. Second toss. What are the possible options we can get with the second toss? We can go either heads, or we can get tails, or for this one we can get heads, or we can get tails. And for the third toss, we could go again. This could be a heads, this could be a tails, this could be a heads, this could be a tails, this could be heads, this could be a tails, and heads, and tails, sorry. So if we look at all these particular nodes now that we've got, let's come up with the sample space of all the possible outcomes. First one is heads, heads, heads. Next one is heads, heads, tails. Heads, tails, heads. Heads, tails, tails. Tails, heads, heads. Tails, heads, tails. Tails, tails, heads, and tails, tails, tails. So let's answer a couple of these questions now. The question says, what is the probability that 3 of the same sides are tossed? So tails, 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 or heads, heads, heads. Well, let's have a look at how many possible outcomes there are. In this case, how many observed outcomes? We see heads, 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 and we see tails, tails, tails. So in this case, we can say that there is an observed amount of 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 2 out of 8 times, or we can simplify that down to 1/4. So the probability that you get heads, 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 or tails, tails, tails is 1/4 or 1/4. So this last question is not going to be completed for you. However, it's a practice for you. I am going to set up the question for you. So the question says, on a test there are 3 questions. Assuming that there are only 2 answers, right or wrong, create a tree diagram representing possible outcomes from the 3 options. So I'd like you to make sure that when you do this, you set up your first question, you write down your answer, second question, and your third question. Okay, and you make sure that you start off as nodes. You can get that right or wrong, right, wrong, right, wrong, and from there you move on. So this one, you could get this one either right or wrong. You get this one right, wrong, right, wrong, right, wrong. So from there you should be able to come up with a sample space and also answer the question that was presented to you.